Hi, my name is Dave Shanley. This video will show you how to create a simple streaming Async API service and a client using Golang. It should take about 10 minutes. If you want to learn more about Async API, head over to AsyncAPI.com and find out more about the standard and the power it provides us. So, we're going to create a microservice that exposes a single streaming API. It's actually a random word stream service. What it's going to do is broadcast a message containing a random word every second to any subscribers of the channel that it's broadcasting on. One to many, essentially. So let's get started and take a look at the Async API contract. Let's go ahead and look at the definition of the random word message broadcast. We can see it's composed of two elements. Properties defined by transport response and a payload property consisting of a string, which is our random word. This tutorial uses Plank to provide all of these sockets, message broker, boilerplate, and glue code that you typically need to implement Async API services. Now, Plank is actually part of Transport, which operates as an async application framework. Transport will wrap any response emitted by a service with these properties and make the service response available via the payload value. The payload can be anything. It can be an object, a primitive, or a string, anything you can think of. So let's get started by importing Transport into a new project. Next, let's create the directory in which our Async API enabled services will live. Now we can create our new random word service. So let's create a new file called word_service.go. Let's import a few things that we're going to need first of all. Then we can define the event bus channel our service will attach to. Let's call it random-word. The random word service struct defines a string slice named words, which is where we keep our words, funnily enough. But it also defines a pointer to transport core, which actually provides access to transport context and some other useful features, which we'll discuss in a minute. The service also defines readyChan, which lets Plank know that the service has loaded up our random words and is ready to go. The last property is a pointer to a cron job, and that will allow us to execute something over and over forever. Before broadcasting random words, we actually need to add logic that generates a pool of random words in which to pick. So init and onServiceReady are lifecycle hooks. They fire after Plank has loaded the service, init, and once Plank is ready to run the service, onServiceReady. OnServiceReady returns a Boolean chan that Plank will listen for a signal on before completing the activation of that service. So we capture a pointer to it and we call it readyChan. In our implementation, we call fetchRandomWords, which makes an API call using a built-in REST service provided by Transport. It's going to call a public API that will generate random words for us, or as many as we would like. So we're going to ask the API for 500 random words via the REST service and then handle the success or failure of that API call by providing success and failure functions as handlers. In our success handler, handleWordFetchSuccess, we cast the response of the API call down into a string slice. We send a bool down our readyChan to alert Plank that we're ready to go and our words are loaded. Now, if our failure handler, handleWordFetchFailure, activates, we make up some random words of our own and we just proceed anyway. The list isn't very long, but it still fulfills the contract. Let's create our fireRandomWords method. This is the code that'll actually send out our random word to everybody subscribed on our channel. It will use the sendResponse method available via our transport core pointer. The method asks for a response struct that contains a UUID and a payload. The last property is a pointer to a cron job, and that will allow us to execute something over and over forever. Now we can create the getRandomWord method to pull out a random word from our word list. We need to update both of our success and failure handlers to call this new method. It will ensure that the service broadcasts an actual list of random words regardless of success or failure to obtain that data. The last step of building our streaming service is to add in a few more lifecycle methods. First, we want to stop our cron job cleanly when we're shutting down, so we can use on-server shutdown. We don't need to implement the second and third methods, as we don't really need them for this tutorial. However, we do still need to add them to ensure that the contract that Plank requires is fulfilled. Our streaming service is complete. Now it's time to serve it via Plank. Let's create a new directory named server and add a file called server.go to it. The main function creates a new instance of Plank that we name platform server, and it's going to use a default configuration. Next, we create a new instance of random word service and register with platform server. This will run the init and onService ready methods mentioned earlier. The last step is to capture any operating system interrupt commands, like Control-C. So let's run the code. You should see the Plank boot screen, which tells you that the platform is up and running on localhost and on port 30080. The Fabric endpoint is a WebSocket endpoint that is opening and listening for STOMP connections. So, how do we consume it? Let's write a client to connect to our new local broker, subscribe to our new service broadcasting on topic/random-word, and listen for 10 random words, and then we'll disconnect. I want to take a second to explain the essentials of transport and how it works so that the next bit makes sense. Transport is an application event bus that operates as a singleton inside an application. Components or actors can message each other asynchronously using the bus without needing to have a reference to each other. The bus allows the creation of universally available channels that all components in the application have access to. A key benefit to this design is that it makes it easy to build decoupled, event-driven application architectures. A feature of Transport for Go is that it has the ability to bridge instances together without needing a third-party message broker. It has a micro broker built in. Transport can connect over TCP or WebSocket, and it uses STOMP as the wire protocol. In fact, it can connect to any message broker out of the box that supports STOMP. There is a concept of marking channels as galactic in Transport. And this essentially means that an application bus channel is mapped to a broker destination. Under the hood, Transport automatically subscribes to that broker destination and then relays any inbound messages to that local application event bus channel. Marking channels as local will unsubscribe from the broker destination. Okay, I'm sorry. Let's get back to the tutorial. Let's start by creating a new file called client.go. Let's define our main function. First, we create a new message broker configuration that defines localhost and port 30080 as our server address, and that we want to use WebSockets. We set the WebSocket path to /ws, which is actually the default for Plank. Next, we grab a couple of pointers to the event bus and bus channel manager that's provided by Transport. Once we have those pointers, we can connect to our Plank server, which is running locally on port 30080. Let's create a channel on our application event bus called my-local-word-stream. And then we create a stream handler that captures all messages on that channel. We can listen to a channel on our event bus by using the listenStream method. It will return a stream handler that we will define as handler. I know, creative. Next, we map our application channel my-local-word-stream to the Async API channel defined by our service, which is /topic/random-word. Transport defines galactic channels as event bus channels that are mapped to an Async API channel or a message broker destination. We don't want to stream forever, so let's put a ceiling of 10 on our stream by using a wait group. Now we have our stream handler and our wait group defined, we can define functions that handle incoming messages and errors. If you recall the Async API contract, all responses are actually an object that Transport provides, and it contains a payload property, as well as these other properties. Now, you can use these other properties however you like in your applications. In the case of this simple example, however, we're just going to use the payload. We're going to log it out to the console and then mark our wait group as done, which will increment its internal counter. After 10 messages from our stream, the wait group will complete. We can clean things up by closing our stream handler and marking our application bus channel as local. Our client will unsubscribe automatically from /topic/random-word on our broker. Disconnecting is the last step. Let's run the code. Once a second, our service is broadcasting, and our client captures those messages. And after 10 messages, the client exits. And that's it. You're up and running with your own Async API Nano platform. If you enjoyed this video, hit subscribe, leave a comment, and then head over to quobix.com for more adventures in code. Thanks for watching. Until next time. See ya.